Hi students. See, to save the time in classroom, we will do some additional problems in video classes. This is such a question from the present chapter, Alkyl halides and aryl halides. Once I read the question, you may please freeze the video and try to work it out, the problem yourself. Then you can start again the video where we will get the answer. Okay. So, this is the first question. One isomer of pentane gives 4 structurally different monochloroderivatives. The isomer is. We have discussed all these things. So it will be very easy for you to get the answer. Your options are pentane, 2-methyl-butane, 2,2-dimethyl-propane, none of this. So please freeze the video and think for a while, try to get the answer, then come back to get the answer. Okay. Okay, we will see. See, pentane can have how many structural different isomers we have seen that. One is this, normal pentane. Then we have isopentane. Then we have neopentane. Like this. These are the 3 possible isomers of C5H12. And how many different carbons are here? 1, 2, 3, 2, 1. Since there are only 3 different carbons here, we get only 3 monochloroderivatives, different monochloroderivatives from here. Coming over here, isopentane, 1, 1. These are identical. 2, 3, 4. So here we will get 4 different monochloroderivatives. So this could be the answer. And coming over neopentane, 1, 1, 1, 1. All these 4 carbons are identical. And the second different carbon is non-substitutable. So here we get only 1 monochloroderivation. So our answer should be this, isopentane, whose IUPAC name is 2-methyl-butane. So pentane, 2-methyl-butane, 2,2-dimethylpropane, 2-methyl-butane must be the answer. Hope you follow that. I'm sure that you might have got the answer even before my explanation. Okay, we will proceed to the next problem. Our next question. How many structurally different dichloropropane are possible? How many structurally different dichloropropane are possible? Here also they mean structural isomers. And you have option 2, 3, 4, 5. Okay, freeze video, think, get the answer, then proceed. Okay, propane, it is having 3 carbon. Since we have 2 substitution here, we number them 1, 2, 3, not 1, 2, 1. So what are the possibilities? We will slowly think, systematically think. 1, 1 dichloropropane is there. Then keeping 1 chlorine here, we move the other. Then we have 1, 2 dichloropropane. Move the same once again. So we have 1, 3 dichloropropane. Now we start from both chlorine on the middle carbon. Then we have 2, 2 dichloropropane. And if we move one of the chlorine to either this position or this position, that compound is 1, 2 dichloropropane. Not 2, 3 dichloropropane, because 2, 3 dichloropropane is misunderstood 1, 2 dichloropropane. So only you can think in all other ways. You will not get any more than these 4. So our answer for this question will be C4. Okay. The next question. How many structurally different C3H6 BrCl are possible? So this is also a case to find number of structural isomers. Given options are 3, 4, 5, 6. Please freeze the video and think. Okay. Here C3 means derivative of propane. Is it saturated or unsaturated? See, replace bromine and chlorine by hydrogen. Then the formula is C3H8. C3H8 is nothing but propane. So the parent hydrocarbon is saturated. It is alkane or propane. So it is saturated. That's our first conclusion. From propane, in how many different ways you can replace two hydrogen by bromine and chlorine. That is the implication of the question. Okay. Now we start writing like this. Three C's are written, 1, 2, 3. We start with both bromine and chlorine on the first carbon. So 1 bromo, 1 chloropropane. Now we move either bromine or chlorine to the next carbon. Let's move, say, chlorine. So then we have 1 bromo, 2 chloropropane. 1 bromo, 2 chloropropane. Then chlorine can be further moved. Then we have 1 bromo, 3 chloropropane. Okay. Now take both to the middle. Then we have 2 bromo, 2 chloropropane. Okay. Now think about interchanging bromine and chlorine. 1, 1. There is no possibility of interchanging of positions of bromine and chlorine. 1, 2. Yeah, there is a possibility of changing bromine and chlorine's position. You can have chlorine on the first carbon and bromine on the middle carbon. Isn't it? So our new compound will be 2 bromo, 1 chloropropane. 1, 3. There is no possibility of, even if you exchange, the compound will be the same. If you exchange the terminal carbon bromine chlorine, you are not going to get a new variety. 2, 2. You cannot exchange. So we got 5. Think for yourselves and check whether you will get any other isomer. You will see you won't be getting any more. So the answer will be 5. Okay. Next question. Neooctane has dash primary, dash secondary, dash tertiary and dash quaternary carbon atoms. I haven't given any options here. Please work it out. Take your time. Okay. Neooctane. We know how to write it. One, two, three, 4, 5, 6, 7, 8. So this is neooctane. Now we will mark primary, secondary and tertiary quaternary carbons here. This is primary, this is primary, this is primary, this is primary. So primary 4. Now we will mark secondary carbons. Secondary, secondary, secondary. No other secondary. Secondary 3. Now we have tertiary. There are no tertiary carbon at all here. 0. And quaternary. This is quaternary. So you have 1. So total number 4 plus 3, 7 plus 1, 8. There are 8 carbons. So it is correct. So our answer should be like this. 4, 3, 0, 1. Okay. Fifth question. What is the IUPAC name of 3 tertiary butyl pentane? Okay. Try it. Okay, first we draw 3 tertiary butyl pentane. C, 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 C. Now add tertiary butyl group here. C, 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 C. Fill it with hydrogen. Yeah, that's it. Now, see the longest chain 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's a rule that says if branched side chains are there, try to avoid them by making another longest possible chain. Okay, if you take this as the chain, there will not be any branched side chain. See, tertiary butyl is a branched side chain. If possible, without violating the longest parent chain rule, you have to go for that longest parent chain. If you take this as the longest parent chain, you have branched side chain. If instead you take this or this as the longest parent chain, both are identical, there will not be any branched side chain. So we take this as the parent chain, 5 carbon, isn't it? And number in such a way that the locant carbons get minimum number. You shouldn't number from here, you have to number from here. So this will be 1, this will be 2, this will be 3, this will be 4, and this will be 5. Okay, now we can easily name it. There are 2 methyl group on carbon 2, there is 1 ethyl group on carbon 3, isn't it? 2 methyl group on carbon 2 and 1 ethyl group on carbon 3. So we have to name it 3-ethyl hyphen 2,2 dimethyl pentane. It is 3-ethyl 2,2 dimethyl pentane. 3-ethyl hyphen 2,2 hyphen dimethyl pentane without any space. Okay. We will continue later. Take care.